Welcome back, everyone. This is Professor Rood for Physical Science, and we're going to work on some quantitative problems from Chapter 3, which is a chapter about energy. And the first thing that we want to discuss with regard to this chapter is the concept of what work is. In order to accomplish work, the object must be moved. When you apply a force and the object moves, then you have accomplished work. If it goes nowhere, if the object has not moved, even though you applied a force to it, then work has not been accomplished. Two ways we can calculate work: simply the force applied to the object multiplied by the distance through which the object moves. This is how you calculate work along the Earth's surface. If, on the other hand, you are calculating work that requires work against the force of gravity, for instance, lifting something up in the air, we're going to modify that equation to equal mass times gravity times height. So if we read this problem, the work done in lifting 30 kilograms of bricks to a height of 20 meters is what? We are lifting something against gravity, so we would be using the MGH formula right here. So the problem tells us that 30 kilograms is the mass. Gravity on Earth, we're going to use 9.8 meters per second squared as usual. And then we are lifting that to a height of 20 meters up in the air. And so if we multiply 30 by 9.8 by 20, we get 5,880 joules of work. So joules is the unit that we'll be using for work as well as energy. So let's put 5,880 joules. Okay? Let's do another example of work, and this question says a total of 4,900 joules is used to lift 50 kilogram mass. The mass is raised to what height? So a total of 4,900 joules of work is used to lift a 50 kilogram mass. So once again, since we're lifting an object against the force of gravity, we're going to use the equation work is equal to mass times gravity times height. We're going to rearrange this equation, solving for height. So we divide by mg on both sides, and this is where I come up with this formula. So they give us work in this case, 4,900 joules. Mass, 50 kilograms. And gravity, 9.8 meters per second squared. And when we do the math, 4,900 divided by 50 divided by 9.8, we get a height equal to 10 meters. When you are accomplishing work, you want the object that you're using to accomplish the work to be efficient. So the rate at which work is accomplished is called power. So this problem is going to deal with power. So the work a 300-watt electric grinder can do in 5 minutes is what? Well, for power, the unit for power is the watt. So they're giving us 300 watts. They're giving us time and asking us to solve for work. So I've rearranged the equation so that work equals power times time. So I'm going to put 300 watts in for power, and I'm going to multiply that by 5 minutes. And when you do that, you come up with 1.5 kilojoules, 1,500 joules. And if we convert that into kilojoules, which the answer in the back of the, then there are 1,000 joules per kilojoule. and that converts into 1.5 kilojoules as your final answer. One 1.5 kilojoules. Please note that I inverted joules and kilojoules. Those should be just the opposite. All right. Let's continue on with another power example. This problem says a 150 kilogram yak has an average power output of 120 watts. The yak can climb a mountain of 1.2 kilometers high in how many hours? So the question is asking us to solve for time here. They give us the mass. We have power. Watts tells us that this is power. And they give us the height the little guy climbed. Now the first thing that I notice is that we're in kilometers here, and I'm going to want to change that into meters. Okay, so let's just do that here. We have 1.2 kilometers, and there are 1,000 meters per 1 kilometer. That's a little more readable. And that comes out to be 1,200 meters. All right. So now we have our height in the right unit. Now, the next step I would do in solving for t is rearrange the equation so that t is isolated. So we get time is equal to mass times gravity times height divided by power when we rearrange this formula here. Notice also that work we have substituted in mgh because we're working against gravity. So it's not force times distance, but mass times gravity times height. So let's go ahead. I think we're ready to put some numbers in here. Our mass is 150 kilograms. Gravity, 9.8 meters per second squared. And our height we calculated to be 1,200 meters. That's coming from down here. And we're going to divide that by the power that's given to us, which was 120 watts. So when you multiply 150 by 9.8 by 1,200 divided by 120, we are going to get a time of 14,700 seconds. Now the answers in the back of this chapter want it in hours. So let's go ahead and convert 14,700 seconds into hours. So we have 60 seconds in 1 hour, in 1 minute, sorry, and then 60 minutes in 1 hour. And when we multiply, or actually when we take 14,700 and divide it by 60, and then divide it by 60 again, we come up with 4.1 hours. Okay, so that is our answer. Okay, one last power example. 40 kilogram boy runs up a flight of stairs 4 meters high, and it takes him 4 seconds to do that. His power output is what? Remember, power is work divided by time. In this case, work is mass times gravity times height because he's running upstairs. So all we're going to do is substitute in 40 kilograms for his mass, gravity, 9.8 meters per second squared, multiplied by 4 meters for the height, and we're going to divide that all by 4 seconds. So this is a fairly straightforward power example, and when we multiply those numbers and divide by 4 seconds, we come up with 392 watts. So 392 watts is our answer. I'm going to end this segment for Chapter 3. I'm going to do 3 more examples in the next video related to Chapter 3.